plan is to look at a hard Leetcode dynamic programming problem. So we're going to go with distinct subsequences. But after today, after that, I'll probably also need to do some research for graph databases. For uni, that is. So for now though, I'm going to just do one monkey type. I see your message, Spartraw. I'll read it in a sec. Damn, bro. I'm cooking it. Okay, that's pretty consistently good. Hello, Spartraw. Indeed, it is a long time no see. Consistency is 55%, which I don't exactly know what that fully means. But it's alright, that many characters, that's cool to know. Raw is 51 words per minute. So, alright. Any recommendation on where to start data structures and which type of programming to start with, dynamic, etc. So which type of programming to start with? If anything, like, I think that's a vague way to express that question, but I think where to start data structures. Is this from never doing data structures in your life? Because if so, actually, regardless of yes or no, what's it called? Competitive Programmer's Handbook. So, okay, so I would say just use this tool. It's actually pretty good. The Competitive Programmer's Handbook gives you the idea of all the data structures and algorithms. Goes through basic techniques, which might be useful here. If you don't know a concept as well, and this handbook isn't enough, then I would recommend just go to Geeks for Geeks. And Geeks for Geeks has like basically the same types of information that you'd find in this Competitive Programmer's Handbook. But you know, we've got data structures and algorithms. Maybe it's explained in more detail slightly, because again, like this data structures and algorithm, this Competitive Programmer's Handbook is meant for people who want to start competitive programming. But Geeks for Geeks is probably a more foundational resource here. But I would recommend, my thinking is, do whatever you can, understand whatever you can from Competitive Programmer's Handbook. And then for any concept that you don't know, you just go to Geeks for Geeks. So if you have data structures and algorithms under Geeks for Geeks, you can, I guess, right, so they changed the interface a little bit, but up on the top here, you have all the different data structures and algorithms. So, you know, if you want to learn about strings, get that out of the way. Or strings or linked lists, you can go to linked list and you can see all this, I guess, information about linked lists, but where could we find, say, the specific data structure? Right. Yeah. So this is a lot more information, as you can tell. But anything under basics of linked lists, and operations of linked lists, they should be good information to know just about that topic, right? But this is a good resource, right? This is a good resource with lots of information that you can search through. But don't be like bogged down in terms of like having to go through, you know, each one of these in rows, right? So you got like, you don't necessarily need to go as soon as you finish singly linked list, go to doubly linked list. But, you know what you need for, say, solving Leetcode problems. The other thing is like, practice your Leetcode problems. That's another way to like be good at data structures and algorithms. Just do more practice on the specific problem relating to said data structure. That's a good way as well. Okay, so I want to try this dynamic program problem. All good, sparse raw. Okay, so you're given two strings S and T, both consisting of English letters. Return the number of distinct subsequences of S which are equal to T. So if you have CAAAT and cat, your output is 3. So explanation, there are 3 ways you can get cat from S. So you can get cat, cat, and cat. Yeah. x, xy, xy, and xy. So you should expect to be able to do this xy, 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 xy. So you have 5 different ways. Yes. Okay. I don't know if there's a particularly apparent way to do this. You have to use a 2D dynamic programming of some sort. I'm gonna sit down for this now. All right, let's say you have cats and you have cats. Maybe what you do is keep a pointer on each of these, and you know that in the base case, I'm trying to think. To get C, there is one way to get it. You want to return the output, so the number, right, at the end of this. So you need to find the one at T. When you're at C, you know that it's going to be 0 originally, perhaps, because maybe what we have is something like this. So when you increment I, I feel like J has to start from, I'm thinking, okay, in the base case, the for any S, and if J is just the empty string, then you would return 0. What can we assert? S and T is not an empty string. Okay. So if you can assert that, does that mean we don't need to consider the empties? Yeah, I believe so. So let's just say that we don't need to consider the empties. Both the I and J pointers point at C originally in both of these strings S and T. So the way to think of this equation, it's a good question. Hello, Nahi. It's been a long time, man. So my original thinking is, okay, maybe you find the subsequence of cat. So if you find the subsequence of cat, my thing is you start with a subsequence of the target value, t. Start with c, and then you build it up all the way up to c, a, and then t. But from c alone, we know there is only one possibility. From ca, there is 1, 2, 3 possibilities. And then from t, there is still just 3 possibilities. And if you have x, x, y, x, y, and x, y. And when you have x, there are 3 possibilities. And if you have y, three plus not necessarily 3 plus 2, is it? You can add a y to all of them. Yeah. Yeah, no. I think we need to do this as if it's a choice. Oh, thanks, Nahi. Glad you liked it, man. Appreciate it. And hello, Shahjalani. You have caught me again. So I think this is a choice of to include or not to include. So if we start from C, for the CAAT, you could choose to include or not to include A. And then you can choose to include or not to include A again. Choose to include or not to include A again. And then choose to include or not to include T. Can I really do anything with that? Because if that whole path reaches CAT, you backtrack it up. I guess you know you did the right thing. Let me just check something. Okay, the gain settings on this is high. I need to turn down the gain settings. Turn it to half. Okay. I am getting stuck on this, so I'd rather look for some hints. I know the recommended space and time complexity would be around the length of S plus the length of T. Alright, so O of S and O of T. Never mind. Okay, O of M times N. Okay, maybe that gives me a hint here. So that means I might need to build like a 2D array of each of these configurations. Okay, now here. You'd like to hear me talk about my take on AI's advancement, and you've been around too many AI doomers. Yeah, no worries. Yeah, I will have a little more think about this first, and then I'll respond to that. But spoiler alert, it's not scaring me. Okay, so right, so we know the recommended time space is going to be O of n squared. Sorry, O of m times n. If we have a 2D array here, somehow, maybe perhaps we got like CAAT or AAT and CAT, then to get C and C, how many distinct subsequences are there for that? There is one. How many distinct subsequences is there for A and C? So CA and C, there's still only one. How many for CAA and C? There is still only one. But how do you know that, right? So if the C is not equal to A, maybe, then you know you can't do anything. All right, but if that C was here, right, then that means this would be 2, because maybe that C is equal to A, right? So maybe we say that the check here that we have to make is like the string of I and the letter at I and jth position of S and T. If they're equal, then that's when you like increment. That's what I'm thinking. So increment, I don't know, I'll just do like I++. So, not I++. I'll do, yeah, the previous ++, whatever that means. Give me a second. I'm getting asked a question. Alright, so this means that I am meant to write this out somehow. So this means that you might need to take the previous +1. Right, so 1 plus the dp of the previous, whatever the previous is here. Yeah. So in this case, yeah, I mean, you kind of get what I mean here. So I'm just gonna do a rough, very rough understanding. All right. We get one of these two kind of, you check the back of it. Okay. Okay, so then if you get, right, so CAAAT, that means this is 1, this is still 1, this is still 1, because it's not the same. And you have a T, which is still 1. Okay, and then you go and have an A now. So CA and C, that is going to be 0. But why? Right, to get CA and you have a C, you can't do anything. You can't like get CA from a single letter. And so there is a check of maybe I has to be greater than J. But if that's 0, okay. CNA, how do you check that? You know that C and C was a 1. C and A was a 1. So you check if A and A is the same, which it is. So you take the CA above, C and CA above, plus 1, perhaps. Right, so perhaps that's what you do. So maybe then that becomes a 2 straight up, because what you do is, if this is the same, then yeah, so this looks right. It's like right and up is our considerations. Okay, this is up consideration. Is that fine by me? Is that fine by me? Because they're the same condition. Not really. Doesn't really make sense that way. Maybe, but we'll continue. So then you have so another A means you can do it again. So you're gonna have 3 different ways. Is that right? No, right? Because CA and CA, that should itself only be 1 different ways. Right. So A and A be 1 different ways. So I might need to comment this out. And then when you see another A, look at the previous. You know, there's 2 different A's. And you look at another A and that A, there's 3 different A's. And then if it's A and T, well, you can still just take 3. And if it's got t now, so SAT, sorry, CAT and C and A, these are both going to be zeros. And then since A and T don't equal the same thing, you wouldn't add 1 to it. Where A and T are not the same thing again, you wouldn't add 1 to it. And then if T and T are the same thing, you would add 1 to it. Is this the right approach? And then you would take the max of this 2D DP, which means you get 3. I want to try one more, right? So x, x, y, x, y. And xy. Right, so x and x is going to be 1. X and x is going to be 2. Y means you keep 2. X, it means you keep 3. Why is this still just 1D? Like, yeah, I don't think this is right either. So let's just say this is still just 3 at the end. Okay. And this y, so if you have 0, if you have just an x and xy, then it means you can't really do anything, so it's 0. X and x and a y, so you can't do anything still because it's there's no y's yet. Now you see a y, that's going to be a problem because you witnessed 2 x's previously. Alright, so you've witnessed 2 x's previously. There's 2 ways to do that. Right, so maybe you're taking this value. Maybe. And then just pasting it here. Okay, regardless. So now you got an extra x. Can't do anything, so you put a 2. An extra y. So now with this extra y, y plus y, well 3 plus 2 is 5, yes. Alright, if we take this 3 and this 2, technically if we take this 2 and this 0, it's also just this 2 value here. Is that the play? Let me have a closer look. I'm trying to just see the pattern, right? So when we get the t for if we just got the t for CNA, we get the t three and 0 is 3, maybe 0 and 1, 0 and 0 is 0, 1 and 0 maybe is 1, 2 and 1 is 3, 3 and 3 is 6, so that's not, yeah, this pattern searching isn't working here. So I don't think this is the case either. This isn't the right way either. There must be something else that I'll just have to look in the solutions. Although maybe I can try and look at a hint. So anyway, let me answer your question now, Nahi. So yeah, what are my thoughts on AI's advancement? I think it's nice, but it's overhyped still, right? I think there's still too much overhype with that stuff. If anything, it's nice because things can be automated, right? Which is great. Like certain text, any automation that requires text, you can automate it with AI. So that's great, right? That's like a good practical use case of AI. And there's also a lot that it knows, quote unquote, which is also good because it kind of pushes you as the developer to be better than an AI. And it makes you think about things more critically as well. So even if you use AI as a tutor, you can kind of ask the AI itself to clarify its thinking, or like why, or like try and clarify your thinking by asking the AI like, why does this algorithm work this way, or whatever. And that's just helpful for you in general, right? So it's not about like trying to how do I express this? I guess you're kind of both trying to compete with the AI, but it's also that you're not really on the same playing field either. One thing that I hold comfort in is the fact that I know AIs, at its current stage at least, lack a lot of context. Like any physical context in the real world, AIs lack that unless there's some parameter built into the AI to sense that, which I don't think will. I mean, it could be done to a human level where like AI can see the real surroundings, can move the exact same ways that a human can. But that's quite far down the line as well. And I think at the end of the day, you can still decommission an AI, right? I don't think a situation like the Terminator will occur. Because the AIs that we currently have, at least, try to please the reader, right? Please the reader. So anything that, like, say, the OpenAI, what's it called? Like hallucinations, the ChatGPT hallucinations. Those are probably all stemming from trying to, quote unquote, please the user or the reader. So if you notice something wrong with the AI and the AI says, I'm sorry, you're right, it's like a clear sign that the AI is trying to please you, right? Regardless of what they did. So like right now, it just doesn't seem to be there to me. If we're seeing human level intelligence in the AIs, then maybe that's something to worry about further down the line. But as it currently stands, if you have like basic programming knowledge, basic programming skills, plus keep on learning about DSA and stuff, just yourself, you can kind of compete against the AI. I know, like I said before, that you're not really competing. But sometimes you can think about it as a good comparison to have, right? To kind of level your bar of skill level. If there's something that the AI can do right now that you can't, I mean, you kind of got to pick and choose as well here. Because, I mean, you don't want to be doing repetitive tasks that the AI can do. But you want to be finding the things that the AI can do that are more genuine, right? Like finding, I mean, using a certain algorithm to solve a problem. Maybe the AI can still find it better, right, at the end of the day. But I think you having the skills itself to do it, you know, that's still more valued, I think, than an AI doing it. In some senses. Because then you can kind of reason about it. And if anything, like, having an AI there is kind of like a, you know, a bar, a standard, the way you should know. But it's not really the exact standard, right? It's just like you just have a feel for it. Yeah, that was also my mindset. The people who were telling me things like cooked, guys I know I don't even attempt to study and learn in their free time. Yeah, exactly. Right, so, you know, there's those types of people. Yeah, but I think it's like a good thing overall, right, that we have these AI tools. Because for me at least, it does motivate you to try and be better than the tools themselves. So that's what I'm thinking. But not motivate you because of fear, out of fear. Right? Not because it's out of fear, but because I just want to find some skills that, you know, AI can't do. And if this is a forever repeating loop, then so be it. But it still means, like, as a person, I'm improving, right? So maybe at the end of the day, the real problem is of comparison. And instead of comparing against the AI bot, you should compare it against your previous self. Right. It's like the same thing where you don't want to compare against other people. You just want to compare against you the day before. All right, I think that's let's go to the hint. Try to think in terms of recursion and visualize in a decision tree, as we need to explore all subsets of S, subsequences of S. Can you determine the possible decisions in each recursion step? So I believe I am doing the right thinking, or partly the right thinking. To explore all subsequences of S is to explore choosing or not choosing A. Maybe these all become 0. Oh wait, no, that doesn't make sense. Okay, so I think like I'm on the right track. Let's look at hint 2. So we recursively iterate through the strings. Yeah. I and j for s and t respectively. At each recursive step, you can either skip the current character of s or include it in the current path. If it matches the current character of t, yeah. Maybe. Hint 3, so if index j goes out of bounds, we return 1 as the valid subsequence is found. If index I goes out of bounds, we first return 0. At each recursive step, we return the sum of both paths. Okay. If j goes out of bounds, we found a valid subsequence. If I goes out of bounds, we return 0. Right. If I goes out of bounds, we return 0. At each recursive step, we return the sum of both paths. The sum of both paths. So I is out of bounds. So I goes out of bounds first, yeah. We return 0. If j goes out of bounds, we return 1. At each recursion step, we return the sum of both paths. So 1 and 1. 1 and 1, 2. 2 and 1, 3. 1 and 3. No. Oh, wait. So 2 and 1, wait, so 1 and 1. Yes. 1 and 0, yes. 1 and 1, yes. 1 and 2, yes. 1 and 3, 4, but because A and T are not the same, then it's just 3. Sure. And then what? You have a 1 and 0. So because they're not the same, not the same. T, so T and T is the same, so 3 and 0, this should be 3. Is that right? Yes, it should. Should. Fair enough. Yes, that was also my mindset. The people who were telling me things like were cooked. Yep. Yeah, you really helped me with the comparison thing in the past. Every day I write down what I've learned and just look back on it from time to time. Oh yeah. That's it. Super motivating seeing the growth. Exactly, man. That's like, you know, you're already on your way to like mastering the game of life every day, right? Instead, like, you know, I think of this in terms of games, right? You know, you play video games, you play Valorant maybe, just like me, and you convert that to a game of life, which is cringe to say, but kind of good to know. It's kind of good that it comes around to this at the end of the day. comes around to the game of life. Okay, I think I might know how to solve this now, but let me just run this xy option one more time. So 1 and 1 is 1. X and 0. So because x and oh wait, so x and y are not the same. That should be 1. No, it shouldn't. I think that should be 0. So then you got 2 and 0. But you would do nothing. Because x and y here is sorry, x is not the same as y. Then you get a 0. Again, maybe because it's 0 plus 0. And then you say that you have a y now. You take this 2 and this 0 to get a 2. You have an x, so you get 0 plus the 2. So it's just 2. And then you say y and y is the same, so 3 and 2 is 5 plus, yeah, so it's just 5. Okay. So the recurrence relation that I'm seeing here is kind of something like this. So I'm gonna yank this and paste it down here. But what I see is if this is the same, then you take the right and add it with the, so it's not added by 1, but you add it with the dp of I minus 1 j, which in this case is the up position from this ij on S and T. Okay. Okay. Am I thinking in the right direction? And so if it's not the same, else, right? So if it's not the same, then actually I should write it like a recursive relation. So not equal to tj. Then what happens is we just take the previous so the right, wait, the right or the left? I'm doing the left and up. Yeah, sorry, it's the left and up. So j minus 1, which is the left. Plus 0. I guess it just doesn't matter, right? So it's just the left. And then the base case is, so if, so S I can kind of get the base case. I'm so washed I quit gaming, lol, but I agree treating it like a game is fire. Yeah. Yeah, I'm probably washed now as well, you know? Okay. So if I is greater than j, then I just gotta do this. If I is greater than j, then dp of ij is equal to 0. Right? And if j is greater than I, or I is less than j, then I gotta remove the double space on the keyboard. Give me a sec. Keyboard. Add full stops with double space, there we go. Capitalize words automatically, no. Correct spelling automatically? Yeah, no. Show inline predictive text, I would keep that. Mark quotes and dashes. Okay. Alright, doesn't matter. Alright, let me close this now. Close these two. Close this. Okay. And we have a dp ij is equal to probably 1, right? Let me think. I is less than j. I is less than j. If I is less than j, then you would do this calculation. If I is greater than j, wait, if I is greater than j, that's fine. If j is greater than I, that's not. Right? Yeah. So greater than or equal to means I and j could be equal. If they equal, then you can do the check. So how do I know that the left and up would exist? So there has to be base cases for this I got to consider. So when I is greater than j, that's when you would do the checks. Right, so if you have nothing and nothing, maybe that's what I got to do. Maybe I got to redo this, but start from CAAAT underscore. And then we go underscore CAT. So from 0 and 0, if it's the same, then you would return nothing, and nothing would return 1. But in this case, it might not matter. It depends on what the next value is. Okay, so if you have nothing, so if you have 0 and 1, 0 and 1 means there would be 0 here. Okay. Still be 0 here, still be 0 here. If you got cat, so C and nothing, then there's one way to do that, I suppose. Which using this equation kind of works. Alright, so the whole thing is like this would all be 1. And then from C and C, you take 1 plus 0, which is 1. C and A, you just take left, so it's just 1. A and C, it's 1. A and C is 1. Is 1, okay. Then you got C and A. So I is less than J, so that's going to be 0. Oh, it doesn't matter actually. Does it? Right. I mean, that doesn't matter. So if that's 0, that's fine. Then it's A and A, which is going to be 1. A and A, which is going to be 1 plus 1, which is 2. And A, which is going to be 1 plus 2 is 3. And then A, and then T and A is going to be just 3, because you take the previous one. So that means you can set, you can kind of set everything to 0 here, right? Set everything here to be 0. But this means for the final T, we have C and T, which is just going to take the left. A and T, I is greater than or equal to J. Okay. I think that's still fine. And then, so still 0, 0, 0, and then a T there is 3. So that's going to be the output for the dynamic programming we're going to have. All right. So I'm going to say these two come after here. So this is kind of the logic recurrence relation behind this problem. And this is, yeah, okay. No. Okay, I want to comment this out. How do we comment things out? Okay, there we go. Okay, now we can kind of implement the solution, because I actually know what to do now after looking at those hints. Nirav Pandi, hello. Alright. Okay, let's see. So we're going to initialize a DP that is equivalent to a lot of zeros, where you have, say, M is len of S, N is len of T. So you have an M plus 1. And you have N plus 1. And you have something in M plus 1. Range M plus 1. Okay. Yep, so that's columns and rows. Now, so the rows is m, and columns is n. That's not what I want, actually. I do want the other way. So n is going downwards. It really doesn't matter which way you do this, but this is the way that I've written it out here. So now we build this bottom up. So, trying to think. For I in range of m. So for j in range of n, maybe. For j in range of m, so ij, so dp of I and j, so we got to go from 1 to n plus 1 and 1 to m plus 1. So dp of so for all of ij, so for what's it called, for j in range, for j in range of m plus 1, everything is going to be a 1 in the dp 0. Then for, so this is for m, right? The string, yes. And then the t, so downwards, I in range of one to n plus 1 dp of I is I0 is equal to 0. Okay, and then for these rest of these, we get if j, so if j, si, ooh, si is not the right definition, so sj is equal to ti, then dp of this is dp of I and j minus 1 plus dp of I minus 1 and j. Else, if it's not the same, then it's just dp of I and j is equal to going backwards. Now, I is part of t. So if I is part of t, we don't want to go backwards on that. We want to go to the left. Yeah, so if we want to go left, then it's j minus 1. Okay, and then we return the DP at M and N and M. I missed something, didn't I? Yeah, index is out of range. So S of J. J is for M. Yeah, okay, that's out of range for a good reason. So this is J minus 1. Whoops. There we go. No. Your output was 6 when it was meant to output 3. I gotta see this DP at the end of all this. There should be a JSON dumps of this DP, which might be a better expression. I might just go like for L in DP, print L. I might just do this. See the submit. Okay. There's 3 and 3 here. Let me see. Rabbits and rabbits. Nothing. RABBBIT. Nothing. RABBIT. Okay. And RABBB. This is B. It's 3 and 3, which is 6. My output was 6 when you expected a 3. 1, 2, 3. Yeah, you're right. So this is kind of wrong. So you're not meant to add it, just take the max. No way that's the reason, right? Because even in this test cases, surely you had to add them both. Yeah, you have to add them both. We take the max of 1 plus these? Maybe. No, that's not it either. Okay, what I thought to be correct was not. Let me see. So we can use a memorization to cache the results and avoid redundant computations. A hash map or 2D array can be used to store these results. Yeah, that's what I did. Yeah, I think I'm missing something. Hello, Joe Hearts. I'm missing something here. With all that good, what have I forgotten to consider? It is 2 B's. B, B, B. B, B, B. 3 and 3. Because it's B and B. Rabbits. So it's B and B. One and 3. 0 and 1. 2 and 1 is 3. 3 and 3 is 6. But that I is greater than the J. The I is greater than the J. Oh, if the I is greater than the J, I is less than the J. If you have I here, I at number 1, 2, 3, 4, 5, 6, and you're only at the 5 for J, then it should just be 0. And 3 plus 0 is correct. Okay. Is that right? I think that's right. So I need to make this additional thing, I think. So if to be honest, wait. I could reduce computation by going 1 plus. Sorry, I plus. Actually, I could go from I. When it should be set to 0, right? Wait. Something's not right here. Something's not right. Alright, let's make it less annoying. So if I is less than J, then dp of I and J should equal to 0. Is that right? and then continue. If that's not the case, then you would do this. No. I is less than j. Oh, I is in n, j is in m. Did I make a mistake here? Maybe what I mean is j is less than I. God damn it! There's something here that I'm missing critically. So 2 and 0, you're adding 2 and 0 when they are of equal, so 4 and 4, 5 and 5. So less than equal to? No. Have you worked on anything ML related, like personal projects? Not for personal projects, mainly for school projects. Because my main, I guess, interests lie not in ML or data science or AI. I mainly like programming stuff, you know what I mean? I don't that much like working with data. So I like the algorithmic side of AI as opposed to the ML side. That's one thing about me. So this works for these two test cases. So what if I had CAAT? Right. Right, so this would fail. So what would happen here, right? CAA, CAA. We have A twice. We would take the max of 2 or 3 in this case, rather than 2 plus 3, or 2 plus 0. Oh wait. Yeah, no, it has to be the max. If you saw an A previously, then you just want to keep the 3. If you saw an A previously, then you want to keep the 3, which is interesting. No way this is the solution now, is it? No way. Wait, so this 3 and this 2, is this not a... See, A. 3 and 2. A. Wait, so in this case, J for S is greater than I for DP. J is greater than I. So if J is equal to I, which is not the case, it still just needs to be J is greater than I. Mm-hmm. Okay, continue. Okay, that is not right. Okay, I didn't consider the other aspects. Okay, so there is something wrong here. Fundamentally. Yeah, I'm in the opposite. Maybe my interest will change once I get out of the beginner level. Or maybe. But I think you should stick to things that interest you, right? If that is ML, don't think that it's not equally as important. Because, you know, we all respect people that are not ourselves as well, in a sense. Like, we respect the people who really love math if you yourself don't love it enough. Or we respect the people who does software engineering if you don't do software engineering yourself. Regardless. So if you really like ML, don't feel like you have to shape into software engineering. Something to think about also. Alright, well, regardless, like, why am I not getting this right for the longest time? Yeah, there is another aspect to this that I'm missing, so I'm just going to look at the solution here. So recursion, DP, BP, BU. Hello Kizetsu, happy Saturday indeed. Well, it's Sunday for me actually. But happy Saturday evening to you, I suppose. S equals TJ. We add this to consideration. Yes. So how come my initialization is not correct? I know I don't need to set the zeros because the zero is already set. I am close to this. Like, I feel like this should be right then. Like, this is all I needed. But it doesn't work. Wait. We're taking the 1 and the 1. Not the one that I was thinking of. So if I look here at an example, so 1 and 1 gets you this 1. 1 and 1. So 1 and, let's see. 1 and 3 and 0 should get you the 3. Okay. Okay. So what you're telling me is then that I should be taking this. Whoops, no. I should be taking this. Damn, I did not consider that. 2 and 2 should give you the 3. Not 3 and 1, which should get you the 3. Okay, so I did it, I think. Let me just clean some of this up. Damn, okay, so I chose the wrong thing to DP from. It worked in the 2 examples that I had. Okay, I got there in the end. Okay, always coming through with the sage advice. Thank you, man. Okay, no worries, Nahi. Go have your own study sesh, man. And thank you, Sean. Thank you for keeping me motivated on this stuff. Okay, so we did it. It wasn't a hard problem. It wasn't that difficult. We just have a lot of code I played around with before getting the solution. Okay, so I'll write this up. Obsidian. New file. Call this. What do we call it? Oops. Let me see. 2DDP. Distinct subsequences. 115. Distinct subsequences. I used the hints from the problem on Leetcode to solve this problem myself. The hints were as follows. I'm just going to copy down the hints because I feel like Leetcode might change these hints later down the line. These hints are nice. And hint 4. I was able to determine from that we needed a 2D version, that 2D version of strings, like there's another problem that does similar to this. I forgot which it is, but I'm just gonna, rather than what I thought originally, which was an O of m plus n solution. We need an O of m times n version of dp, rather than what I thought originally, which was of m plus n. The rest of the hints helped me to identify which cell to use during the bottom-up dynamic programming. Solution. So technically, right, this is a dynamic programming. We have, technically it's like a string. Strings, I know this is like the first time I ever mentioned strings. Yeah, okay. I was able to get most of the solution correct. Just needed to realize that one of the realize that my recursive relation was off by 1. But I didn't notice this off by 1 because it looked to be correct. For the 2 examples I gave, I used, i.e. CAAT with CAT and XXY with XY. However, I should have also tried something like CAAT, CAAT, and CAAT. My recursive relation changed from, after doing that, my recursive relation changed from this to that. Okay, cool. We can save this solution. I might save the whole thought process. Yeah. So it has to be this that I copy. Return, I'll just get rid of all that, just make it simple. And then I'll need to go to Ghosty. Okay, what's this called? So distinct subsequences, but it is 115. I still cheated, or I still... But I only had to change one line. Okay, and I can paste my solution here as well. That should work. Awesome. I can probably remove all this. Okay. Edit distance, burst balloons, something or other. Ooh, graphs. Give me a sec, I'll be right back. Let me quickly see the solution. So you could do bottom up, spaced optimized. It's just O(n). Let me think why. Keep a O(n), where n is the length of string t. Sure. Keep an xdp. As opposed to a 2D DP. This is the optimal. This is not the same. Maybe it doesn't matter. Rabbit. I'm just watching this now. Are we quick about this? Oh, you guys can't hear this.
Start at the first character of this, the first character of this. They exactly match each other, right? So, okay, that's good. So now we're going to look at the sub problem, right? We found these two match exactly. Now, how many different ways can these subsequences match each other? Now, how many ways can we get this string? How many subsequences of it can we get that match now the remainder of this string? Now we see, again, both of these characters are A. So far they're exactly matching each other. That's good. And we get to a B, these B's match each other, that's also good. So far we're getting pretty close to getting a subsequence of this to exactly match this, right? We only have to match 3 more characters. We see another B, that's good. But now we see we're looking for an I, right? We need an I and a T so that we can create an exact subsequence of this. But so far we have a B, right? So what are we gonna do in this case? So far what we've been doing is we've been basically evaluating this. We've seen that at the I pointer, which is corresponding to the string S, and the J pointer is corresponding to string T, if the characters at those corresponding positions match each other, we're basically just incrementing both indices, right? Because we're just trying to match that string T, right? So if both of the characters match, we can continue to move on, right? So this is going to be the else condition where we just got to right now, right? We're looking at B in the string S and I in the string T, right? They don't match each other. So what we're going to do is we're going to take I and increment it by 1. We're going to take the I pointer and then shift it to this next character over here, right? Why are we leaving J the same though? Basically our J pointer is over here and it's going to stay at this character. Why is it staying here? Because it's required for us to match every single character in string T, right? That's what the goal of this problem is. We need all subsequences from S that exactly match T. So what we're doing is, so for now, we're just saying this B, we're skipping it, right? Now we're going to look at the next character. Maybe there's some ways that we can match the remainder of this string to this string. Okay, so now our I pointer is at this character I, our J pointer is at this character I. So in this case, the characters do match each other. So what are we going to do? Similarly to what we did before, we're going to increment both indices by 1. We can move to the next position. So we're at this character now in S, we're at this character now in T. Once again, these characters exactly match each other. Right, so once again, we're going to take both pointers and shift them by 1. Now we get to a base case, right? Both strings are empty. So what are we going to return in that case? Basically, that tells us we went through every single character in T, right? And we matched every single character. Now there's no characters remaining, right? So what would the count be in that case? How many subsequences of an empty string can we match to another empty string? Basically just 1, right? That's our base case. We're returning 1 now. But my question to you is, hold on a minute. We're returning 1, right? So our result happens to be 1. But in this problem description, they returned a 3. Why is that? How did they get 3 different ways when our current algorithm that I've shown you, these 2 conditions, only gave us a single one? So what did we end up missing? Well, let's take a look at their explanation over here. They say there's 3 different ways. Why is that? Well, when you take a look at the B characters, right? What we originally said is this B is going to match this B for sure. And that's the only way that we did it. And then basically we took, like over here, you can see we took our pointers and incremented them both by 1. Then we went to the next B. But that doesn't necessarily have to be the case. Isn't it possible just because these characters match doesn't mean we have to require them to match? We can say, hey, let's just skip this B. Even though it matches this B, maybe there's another B over here that can also match this B. So what I'm saying here is if these characters match each other, right, with this if condition, this is one way we can do it, but we can also do another thing, which is we can take our I pointer, increment it by 1, and take our J pointer and leave it the same. Basically, we're doing over here what we did down here. So in this if case, we're going to take both of these results, basically counting the number of ways that we could compute subsequences with both of these and totaling them up, and that's what we're going to end up returning. So what would happen if we ended up skipping this B and then let's say we took this B and matched it with this previous B, right? Then what would we get? Well, then we'd get to these pointers, right? And again, we can say, okay, these B's are now going to match each other, right? And then these 2 I characters are going to match each other, and then the T's are going to match each other. So that's an additional one way that we could take a subsequence of S and turn it into T. So that's another way. So far, our total is 2. So what's the third way that we could do it? Well, once again, we see that this B matches this B, but it doesn't have to be that way. In another way, we could say, okay, these B's match each other. We're going to now skip the second B, and we're going to say, okay, these 2 B's are going to match each other. So that is what the third way would be. And then, of course, we'd have our I's match and we'd have our T's match. So this covers exactly what we're going to do if the characters match each other, and this is what we're going to do if the characters don't match each other. We're going to do this recursively with depth first search or backtracking, whatever you want to call it. And we notice that we're probably going to be doing a lot of repeated work, meaning when we're calling that function, we might be passing in the same I value and same J value into that function. So we're going to use a cache so that we don't repeat the same work twice. And so how big is that cache going to be? Well, how many possible ways could we call our depth first search function? We could call an I value for basically the length of our string S, and we could call a J value for the length of our string T. So basically the number of times we could call it is going to be the length of both strings multiplied by each other. Let's just say that's big O of N times M. So that's going to be the memory as well as the runtime of this algorithm, because we're going to be caching it. I've solved a lot of DP problems with the bottom-up approach, so this time I am going to be using the recursive approach, which is top-down. But there's one last thing I want to cover before we jump into the code. Let's look at 2 more base cases. So let's say our string S had a single value A, and let's say our string T was empty, right? So it's an empty string. How many subsequences of our string S can we take that convert exactly to T? Well, only a single one, right? So basically, if we just take this entire string and just don't take any characters from it, that counts as a subsequence. So this is going to return 1. So basically, if our string T is empty, because we remember the previous case where let's say string T and string S were empty, right? If they're both empty strings, then in that case, we're also ending up returning 1. So basically the condition is if our string T is empty, we return 1 as the base case. What about the opposite case where our string T is non-empty? We have an A here, but maybe our string S is empty. Now, once again, the question is how many subsequences of this string S can we take that exactly match the string T? We're looking to exactly match the string T. Well, since this is empty, there's no characters in it, we can't possibly get an A from this. So we can't possibly match this A character. So therefore, in this base case, we're going to end up returning 0. There's no subsequences of the string S that match string T. So that's all that we need to cover. We have our base cases handled, and we have this logic that we are going to be using. So now let's get into the code. So as I mentioned, we are going to be using a cache. You could use a two-dimensional array for this, but I prefer using a hash map or dictionary in Python because it just is a little bit easier for me. So we're going to be passing two parameters, I and j, which tell us the corresponding positions of string S and string T that we're currently at. We know that one base case is if j has reached the end of the string, that means string T is empty. That means we can return 1 as the base case as we previously discussed. The other base case is if we reach the end of string S, and that means we can't possibly match the string T anymore, so we're going to return 0 in that case. Last base case is if this IJ pair has already been computed in our cache. If that's the case, then we can return the value that is stored in our cache. So then we remember there's two cases for the logic that we have to cover. So if S of I matches exactly T of j, then we know we're going to be running depth first search. We're going to be doing it two different ways. We're going to be looking at the remainder of string S and the remainder of string T. And we're going to also be calling depth first search with the remainder of string S, but the entirety of string T. So we're going to be incrementing I, but not incrementing j in this case. And we're going to call both of these and total up the result. And then once that has been totaled, we can return it. But before we return it, we want to make sure that we cache it. So let's put it in the cache at position ij. The else condition is basically the same thing as this, except I'm going to copy paste it. So except this portion, right? Since these characters don't match, we have to only shift our I pointer. We still have to look for a character that matches the character at position j. And once either of these has been computed, then we can return whatever value we ended up storing in our cache. And this is the entirety of the depth first search function. Pretty short because we didn't have to pass in a lot of variables into it because I defined this function inside of another function. That just makes things easier for me. So now all we have to do is call it. So let's call depth first search starting at 0, 0 for both of the beginning of the strings, and then we return the result. So this is going to be big O, n times m, basically multiplying the length of the strings together, time and memory complexity. I hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon. Thanks for watching.
Nice. Give me a sec. FG star index to solve this problem. Cost of processing a subgraph. Query using most existing indexes. Mainly consist of two parts. Index probing cost and the candidate verification cost. Okay. Index probing is to find the query in the index. Candidate verification is to test whether each graph in the candidate set is indeed a supergraph of the query. We design FG star index to minimize these two costs as follows. Interesting. So this is an efficient query processing on graph database. Okay, so this is one of the ones, okay, called FG index. Okay. Let's see if there's a way to make this better. Hmm. Hello, Zahib. Yes, that seems to be the case. Soon. Hmm. Zahib got the full-time return offer from Amazon? Yes. Yeah, I'm cooking. Trying. Yes. Hello, good morning. Remote? No, so I'll be moving. Hello, ready. It'll be on site in Sydney. Yeah, Sydney's where the tech industry is at in Australia in general. I'm gonna go eat lunch now, so bye bye. Peace.